Hey guys, welcome back to another video. And today we're going to be talking about linear equations and everything to do with them. So this is really the basis of algebra. So here I have a problem, x minus 7 equals 12, and the prompt says to solve for x. So the problem is with people when they go to algebra is they get intimidated by these letters. Why do we have letters in math? Really, letters are placeholders. Think of it as placeholders. It could be any number. It's a number we don't know yet, but think of it as we can solve for it. So this number could be 4, it can be 5, it can be 6. So how do we go about solving this problem? So keep in mind that x right now, what this means is this unknown number minus 7 equals to 12. Now right away you could look at this and you could use just basic logic and say, well, I can just keep track any number, and it can be any number I can find, and it can be 12. But as you go on in higher level math, it becomes very tedious, and really there's a more efficient way to solve this. So think of it as we need to isolate x. So right now this is saying the number minus 7 is equal to 12. Well, we don't want to know the number minus 7. We want to know what the number is itself. Okay, that sounds complicated, but really, we want to get, when we're doing any problems that have variables, we always want to isolate the variable so we know what it is in its pure form. So we can't have anything attached to it. So how can we get rid of the 7 right here? We can add 7 because we want to isolate it. If we do minus 7 plus 7 is 0, so that means we get rid of it. If we, remember, if there's an equal sign, that means if we do something to one side, we must do it to the other. Because then if we just add it to the left side, and we just treat it as if it's x equals 12. First of all, it wouldn't make sense because we can go back and check our answer. 12 minus 7 is not 12, so no. Secondly, it breaks the rules of equality. Equality states that these two sides are equal to each other, okay? If we change something to the other side and we don't apply change to the other side, then it won't be equal, correct? It won't be balanced. So let's go back. X minus 7 equals to 12. Let's add 7 to the side to make it 0 to isolate it, and let's add 7 to here. Correct? And from there, that's our answer. X equals 19. Now, if we plug this number, what this means, x equals 19, that means 19 is equal to x, and x is equal to 19. That means we can plug in 19 into this number, into x, and we get 19 minus 7, which is equal to 12. So this is a cool thing. Always check for it. These equate x equals 19 and 19 equal to x are the same thing, so you can plug them back into it. So let's try another problem. Let's try x plus 9 equals to negative 4. Okay, so let's go ahead to isolate. So minus 9, minus 9. Minus 4 minus 9 is minus 13 because we're going back on the number line, correct? If we're at minus 4 here, then if we minus 9, we're going back, and so forth. So x equals to negative 13. Correct, because if we plug it in, we do negative 13 plus 9, we get negative 4. So that means that is correct. Good. Now let's work with something in 2 steps. So 5x plus 3 equals 28. Now let's do what we did in the last problem, the 1 step. Let's minus 3. And this is actually correct. But if we go back to the original problem, it says 5x plus 3. 5x is the same thing as 5 times x. So that means, and we had this plus 3. So if we translate this to English, that means x, the number x, the unknown, 5 times that number plus 3 will give you 28. That's what this means. That's what this means. It's 5 times the unknown number plus 3 equal 28. This is important for interpreting word problems because remember, when we're isolating, we have to do the opposite sign to get rid of it entirely. So let's try this one. So 5x plus 3 equals to 25. Let's remove this 3. So we get 5x equals to, it's 28, equals to 25. Now we have a 5 times x. How can we do the opposite? It's dividing. So if we divide by 5, 5 divided by 5 is 1, and we do as here, So if I divide by 5 is 5, so we get x equals to 5. So let's plug in 5 into here. So if we do 5 times 5 plus 3, we get 25 plus 3, which is equal to 28. So this is verified. Let's try another one. So we have 4x minus 6 equals to 10. How do we solve for this? So we add 6, we have 4x equals to 16. Now, we isolated use subtraction, addition, because in this time they were subtractions, we have to do the opposite, because we always have to get 0, correct? When we're doing with subtraction. With division, if we have it just 1, it'll just be 1 times x, which is the same thing as x. So let's divide by 4 here. We divide by 4 here, we get x equals to 4. If we verify 4 times 4 minus 6, we get 16 minus 6, which is indeed equal to 10, so this is verified. Great. So that was 1 step and 2 step. Isn't that difficult? It just takes a little intuition. So let's try something like this. So 3x minus 2 equals 2x plus 4. Okay. Now we have unknowns on both sides. We can't have that, can we? Yes and no. It depends on how we're able to use this. So the distributive property, if you've learned, since this is 3 times the quantity of x minus 2, we can distribute this 5 because this 3 is being multiplied by everything inside of here. Correct? And we can expand. Okay? We're going to expand. So we get 3x minus 6. Do the same thing here. We get 2x plus 8. Okay? And when we have unknowns on both sides and they're both like terms, like x's, if this had been y's, we couldn't have solved it. We can't. It's two unknowns. But since these are x's, that means we can move them to one side and we can move the constants, ones without variables, to the other side. So let's do that. So minus 2x, so we get x minus 6 equals to 8, and we add 6, so x equals to 14. If we check that, if we do 3 times 14 minus 2, we follow PEMDAS, we do 36, because it multiplies to 2. And then we have 2 plus 14 plus 4. So 2 times 18 is 36, so we get 36 equal to 36, because we're following PEMDAS, which is parentheses, exponents, multiplication, division, addition, subtraction. I did the parentheses first because they were inside. Parentheses is before multiplication. So let's try another problem. Let's try this one. So 4 times x plus 1 equals 3x minus 5. So when we have something like this, we always want to distribute. So let's distribute. So 4x plus 4 equals 3x minus 5. Let's subtract. Let's get everything on one side. Like terms with like terms. X plus 4 equals negative 5. Subtract by 4 is subtract by 4. X equals negative 9. So 4 times negative 9. So 4 times negative 9 plus 1. It's not 91. So 4 times negative 9 plus 1. So this is negative 8. So negative 32 is equal to 3 times 9, which is 27. 27 minus 5, or 27, negative 27 plus negative 25 is negative 32. So this is indeed verified. Great. So it's really, everything builds from one step. Okay, this was just a whole nother step that we were just working on. So that's great. Okay, so now let's talk about linear equations with fractions in them. Okay, so we have something like x over 4 minus 1/2 equals to 5. So there's a few ways you can do this problem. So I could do is I could constant on one side. So let me do that. So plus 1/2 plus 1/2. Okay, so x to the 4 equals 5 plus 1/2. So I'm going to do the common denominator between this right here. So I'm going to get x to the 4, x divided by 4 equals 10 plus 1 all over 2, which is 9 over 2. So x over 4 equals 9 over 2 times by 4 times by 4. So we get x equals 36 over 2, which is 6. Yep. No, it's 18. Sorry. So if we verify, if we do 18 divided by 4 minus 1/2, divide by 4 Yeah, this is correct. Should be correct. Yep. So let's try this one. Did I verified it and it's not right. Let's try something else. So if we do x over 4 minus 1/2 to 5, let's just try multiplying everything by 4, because remember the common denominator, because remember if we have x over 4 and remember we have a common denominator. Remember with subtracting fractions you have to have a common denominator. So the greatest common denominator is 4, and the trick is you get 4 on top and you divide all the denominators. Your remainder is you times on the top, so it becomes 4 divided by 4 is 1, so it's 1 times x minus 2 times 1 equals 20. So you get x minus 2 equals 20, so you get, yep, x equals 22. Yeah, that works too. Okay, let's try another one. I made a mistake. Anyway, let's try this one. So 3x over 5 plus 2 over 3 equals to 4. So let's times everything. Let's see, by 15. 15 would be common denominator, so we get 9x plus 10 equals to 15 times 4. What is that? I don't know. 15 times 4 is 60. So 9x equals to 50. Let's see, so x equals to 50 over 9, which is really, so 350 over 9 divided by 5 plus 2 over 3 gives us 4. That's x. Okay, so that's how you do it.